Alright, hi. Today we're going to be working on section 122, solving proportions. And we're going to work on three different ways to solve them. You can pick your favorite. They're actually very similar once you break them down, but they'll work out okay. So they give us a story problem about a guy making some cranes in our book, and this is going to set up these proportions. So we got Kenny, who's making origami cranes, and he can make 7 of them in 10 minutes. So over here we have our proportion, 10 minutes to 7 cranes. But he reads this book about a girl who makes 1,505 cranes, and he wants to know how long that would take him, based on what he knows, to calculate his missing amount of minutes to make as many cranes as she made in the book. So there's 3 basic ways content shows us how to do this. We have the giant one, undoing division, and the fraction buster. You can pick the one you like the best. We can kind of go from there. If you don't like any of them, then there's always going to be another method called cross products that we can discuss too, which is kind of like all these put together in a way. So the first one we can do is the giant one. The giant one basically says what we're going to do is we're going to find a number, same on top, same on bottom, that's going to turn into 1,505. So we start with 7, and we need to know what times 7 gives me 1,505. And if we find that out, we can end up multiplying the top by both. That's the first strategy. So let's try to figure that out. If we were to calculate it, we would have 1,505 divided by 7. If you have a calculator, it's going to be a lot easier. If not, you can always do it on paper. So if we calculate this, 1,505 divided by 7, we can start putting these in. So it goes in there twice. 14, 10, 1, 7, 35, 215. It works out exactly with no remainder. So that's in good shape. So if we take that 215 and we plug it in here and we plug it in here, we're multiplying the same thing top and bottom. We already know 7 times 215 is going to give us this because we divided. Now we just have to solve the top. So we have 10 times 215. We end up with x equaling 2150. So that's how many minutes it would take him to build that many cranes. The undoing division kind of works like this. If you have your missing number, your x in this case, which is a letter, but it stands for number, we want to get rid of this bottom denominator. So what we're going to do is multiply both tops by 1,505, which is kind of the same thing we did here, right? But a little bit different. So if I multiply this on both sides to the tops, I end up with, on this side, 1,505 divided by 1,505 is 1. So I just get x over here. That's why this is important, because now we can just get x all by itself. Now when I solve this math problem, I'll end up with my answer, which we already know is 2,150. So I multiply, and I end up dividing, and we end up there. So we go that route. Let me see if that's correct, actually. I think that one might be weird. Let me see. Oh, no, we're going to be okay, because we're going to end up with a great big number to end up with what it is. So, yeah, we're in good shape still. Okay, so we end up with that divided by that. We're still going to have 2,150. Again, grab your calculator, multiply it, divide it, go from there. As far as this one goes, the fraction buster, what we're going to do is kind of do this again, but we're going to multiply both of them. So we want to get rid of both bottom numbers. So what we're going to do is multiply all of this top by 7 times 1,005 like this. Multiply all of this top by the same thing. And that'll get rid of both bottoms basically. And it will give you what you're looking for as far as your answer that way. So it's going to give you a couple different ways to solve it and go from there. So let's take a couple of examples quick. So they give us some story problems that are kind of interesting. The first one is going to talk about, I'll skip A, we'll go to B, the tamale sale. So a school is going to have a tamale sale, and they want to see how many tamales they should make so they can sell them. Well, we don't want to just make a whole bunch of them and have a bunch of leftovers, and we don't want to have too few and miss out on the chance to make some money. So they figured out, they asked 80 people during lunch, randomly, who would want to buy a tamale for sure. And the 15 people said yes. So we have 15 people that said yes over our total people we asked, just like that. So these were our yeses over our people. Now in the whole school, they don't have 80 people, they have more than that. So in the whole entire school, they actually have 1,600 people. So we want to find out how many people that would translate into for this top number. So I'll show you a different method now called cross products that some people like to use better than the other ones. So this is essentially X, our missing number. Some people put a box, some people put an X. It's up to you. Our book actually puts an X there for a missing number, so we're going to get like an X equals answer. And if we do this, I can do cross products. So I go 80 times X, and I could just write down here 80 times X. That's going to equal this times this. So 15 times 1,600. Now when I calculate that, I'll end up getting my answer on this side, and then I got to get X alone. So again, if you have a calculator here, it's going to be a lot faster. If you don't have a calculator, you can speed through this, but we're going to end up getting 300 when it's all said and done. So we're going to have 300 tamales. We end up with X equals 300. So I skipped a step there for you, but if you have a calculator, really simple. 15 times 1,600, then divide it by 80 to get X by itself, and you end up with 300 tamales. So for the whole school, 300 people would buy the tamales and you'd be set. We'll do one more. It's kind of geometry related, and then you'll have enough proportions to get started. So let me just get rid of this one quick. I'll do my best to draw some triangles here. So triangle number one, although they don't call it number one, looks like that. And the second one I'll just draw over here like this, a little bit smaller. Watch out in math books, these are hardly ever to scale. Mine aren't going to be a scale either. So use the numbers, not necessarily the scale. Let's say this side is X, that's our missing side. We don't know what it is, but we know this side is 12. So it could be double, could be, we don't know yet. This is 22, and this down here is going to be 8. Okay. So if I have a really cool, nice relationship between 8 and 22, I'm good to go. Like if this is 16, I just double it, and then I know 12 times 2 is 24. But that's not exactly double. It's going to be something different that we don't quite know. So we're going to want to set this up as a proportion. So what we're going to do is find one number from this triangle that matches up with the number on this triangle. So I don't want to do 12 or 22 and 12 because they're opposite sides. So I'm going to keep my sides the same. So I'm going to go 22 and 8 because they're kind of the same sides but on different proportions. So I'm going to set it up as 22 over 8. And I'm going to say that's equal, because we're going to do a proportion, to, well, if we did 22 first, we did this triangle first, that's got to go on top. So I'm going to stick my X right here, that comes from there, and I'm going to take my 12 from this triangle and put it down here. And now we're set with the same situation we had before. You can choose the method you like the most and solve it. In my case, I would probably cross multiply. So I like to do this first. I get 8x, and then I can go equals 12 times 22. Again, if you have a calculator, type it in. I don't happen to have one, so I'll try to do it really fast here without messing up. And I think that I get 264. And then 264 divided by 8 should give me my answer, which I don't know right now, so I'll try that. 264 divided by 8, I got a 3, 24, 24, 33. So X is 33 in this case. Now we got to check and make sure it makes sense. If this was bigger than that, that would be, okay, we're good. 33 could work. So it looks like it's a proportion bigger than that. So this is going to be our proportion stuff today as we go through, and you're going to see a lot of these popping up in 8th grade math for sure, where we have to figure out what's missing, what you have, what you don't have, and hopefully this will get you started with 1, 2, 2, solving proportions.